Okay guys, so I have two more examples. The first one is asking us to prove the conditional statement. So I have two premises, R and Q implies S. The second premise, not P, implies R and Q. And then the conclusion is not S implies P. So prove this. How do we do that? And then I have another example where we prove a theorem. Okay, so this is premise. So this is another premise. I just numbered them, premise 1, premise 2. I'm going to note the conclusion somewhere here, not S implies P. This is what I want to show. But I'm going to erase this because I would like to prove this statement. So because I am trying to prove a conditional statement, this statement is true means not S, if not S is true, then P must be true. So therefore, I am opening a box. So I'm doing a subproof, and I assume that not S is true. So if not S is true, so this is assumption for conditional derivation. So if not S is true, well here, use premise number 1 and line 3. So this is modus tollens. I must have not R and Q. All right, so this is modus tollens between line 1 and 3. Okay, so what do we learn from this? Well, once I have not R and Q, and because I have not P implies R and Q, so again, I can use the modus tollens property again, so I must have not P. This is thanks to modus tollens of arguments 2 and 4. So I know that this is double negation. It is equivalent to P, double negation of the argument in line 5. So if not S is true, P must be true, which is exactly what I was trying to conclude. So I finished the proof that not S implies P. So this is how we prove that this argument with these two premises and this conclusion is a valid argument. Now I am going to look at the theorem. So the theorem has no premise. Fine. I start with assuming that P implies Q, right? This is the first argument, implies the second argument. So this is the conclusion that I am trying to reach. Okay, but the thing is, the conclusion is also a conditional statement. So this is assumption for conditional derivation, but then I assume R implies P. This is also assumption for conditional derivation. All right. Now I need to show that R implies Q is true. But R implies Q is another statement, another conditional statement. So therefore, I have to open another box and assume R. So this is assumption for conditional derivation. So I make 3 assumptions consecutively, I'm sorry. P implies Q is the first assumption, R implies P is the second assumption, and then R is the third assumption. So what do I know if R is true, given that the other 2s are assumed to be true? If R is true, by using 2 and 3 and modus ponens, I must have P. Modus ponens between the arguments 2 and 3. All right, once I have P and P implies Q, again modus ponens, Q must be true. Modus ponens between the arguments 1 and 4. All right, so if R is true, I just show that Q must be true. So now I can close this box because I just shown or proven that R implies Q statement is true. Well, so this is true statement. Remember in assumptions that this is conditional derivations thanks to argument between 3 to 5. Because I assumed R implies P and show that R implies Q is true, so this entire conditional statement is also true. So I also close this, all right? And then the 7th line basically says P implies Q implies R implies Q. All right? Oh, I am sorry. What am I? I'm sorry. R implies P implies R implies Q. All right? Thanks to argument. So this is conditional derivations thanks to arguments between 2 to 6. So once this conditional statement is true, now I close the entire proof by saying that, hey, you know what? If P implies Q is true, which was my first assumption, well then this statement, this long conditional statement, R implies P, if R implies P, then R implies Q is also a true statement. And hence this theorem is true, that this argument is true. And hence this is the proof of the theorem. Hope that is clear.